Hi, I'm Miss Hearn. Let's get started. In this video, we're going to answer the following question. Suppose that the line tangent to the graph of f at x equals 2 is y equals 6x plus 5, and suppose that y equals 3x minus 1 is the line tangent to the graph of a function g at x equals 2. Find the line tangent to the following curves at x equals 2. And the following curves, A is a product of f and g, and in B, the curve is the quotient f over g. So in order to answer this question, to find the tangent line of a curve at a particular point means finding the derivative evaluated there. So the first important fact I have listed is f prime of a is the slope of the tangent line to f at x equals a. So we're going to have to find the slope of the tangent line by plugging the number 2 into the derivative of each of these functions. And to find the derivatives of those functions, since they're products and quotients, we'll have to use the product rule and the quotient rule. So let's look at a first. So for part A, notice that we're going to have to use the product rule. And the product rule tells us that, it's over here, by the way, on the right. If you have h of x equals the first function times the second function, so I've used f for first and s for second. The derivative of h is the first times the derivative of the second plus the second times the derivative of the first. So we're going to apply that idea over here. We're going to find y prime. Y prime is going to be the first function, f of x, times the derivative of the second, plus the second function, g of x, times the derivative of the first. All right, so we, in essence, have a formula, but we need to be able to find these values when we plug in x equals 2. We're interested in evaluating this at x equals 2. That means that we're going to need f of 2, g prime of 2, g of 2, and f prime of 2. But look, we were given some information. First of all, since y is equal to 6x plus 5 is the tangent to f at x equals 2, that means, notice that this tangent line has a slope of 6. That means that f prime of 2, the derivative evaluated at 2, has to be 6. And also, we know that since y equals 3x minus 1 is tangent to g at x equals 2, similarly, that must mean that 3 being the slope of the tangent line, g prime of 2 is equal to 3. So we have f prime of 2 and g prime of 2. Now what we want is y prime of 2. And we figured out the formula for y prime, so we're just going to plug into that formula what we need. We need f of 2 times g prime of 2 plus g of 2 times f prime of 2. Now, we already saw that f prime of 2, which is here, is actually 6, and g prime of 2 is 3. So you might be wondering, though, how can we find f of 2 and g of 2? Well, remember that when you have a function and you have a line tangent to that function at a particular point xy, that point xy is actually on both the tangent line and the function itself. So we're being told the x value of that point, and we can plug into the tangent line to figure out what y value goes with it. So for f, I know that it has the tangent line y equals 6x plus 5. So when x is 2, y is equal to 6 times 2 plus 5, which is 12 plus 5, or 17. So this y value, f of 2, has to be 17. Similarly, we have the tangent line to g at 2. So when we plug in 2 for x, the tangent line equation y equals 3x minus 1, we get 5. So that means that both the function g and its tangent line go through the point 2, 5. So this function value, g of 2, is actually 5. So y prime, which is the slope of this function y, at the point 2 is going to be 17 times 3 plus 5 times 6. So the slope of y at 2 is 81. So now we have the slope of our tangent line, and we just need a point, because all we need is a slope and a point to write the equation of the line. Well, we do know about one point on the function, y of 2, because we know y equals f of x times g of x, and we know what f of 2 and g of 2 are. We know that y of 2 is the product f of 2 times g of 2, or 17 times 5, which is 85. So what that tells us is that the function y goes through the point 285. That also is the point of tangency. So that is a point on the tangent line. And so we have the slope m, and we have a pair of coordinates x, y, so we can write the equation of the line. Well, my favorite way to write the equation of a line using given a slope and a point is to use y equals mx plus b. So I plug in the coordinates of the point for x and y, and I plug in the slope for m and solve for b. In this case, we would get negative 77. So the equation of the tangent line to the graph of y equals f of x times g of x at the point x equals 2 would be y equals 81 times x minus 77. For part B, we can work it similarly. First, we would apply the quotient rule, and we would see that y prime of 2 is g of 2 times f prime of 2 minus f of 2 times g prime of 2 over g of 2 squared. As we just discussed, g of 2 is 5, f of 2 is 17, f prime of 2 is 6, and g prime of 2 is 3. So we can plug those into y prime of 2, and we see that the slope of the tangent line to y equals f of x over g of x is going to be negative 21 over 25 at the point where x is equal to 2. So we have the slope of the tangent line to this other function, and now we just need a point on the function. Just like before, we can figure out the value of y of 2 by plugging in to f of 2 over g of 2. So y of 2 is going to be f of 2 over g of 2, which is going to be 17 over 5. So what we know is that our tangent line we're looking for goes through the point 2 17/5 and has a slope of negative 21 over 5. Plugging x, y, and m into y equals mx plus b and solving for b, we get that b is 127 over 25. So that means that the tangent line to the graph of y equals f of x over g of x is going to be y equals negative 21 over 25x plus 127 over 25. I hope you found this video helpful. If you did, please remember to give it a thumbs up. Every time you like it, that helps other students to find the video.